Hi guys, in this video we're going to have a look at modelling with sequences, and that's both types, arithmetic and geometric. So let's have a look at this first question. Loads to read, loads to take in, so let's just take our time, and if you feel confident enough at any point, pause the video, have a go at the questions, hit play and see how your answers compare with mine. So we've got a guy, Bruce, starting a new company, and in year one his profits will be £20,000. Not bad. His profits, he predicts his profits to increase by 5,000 a year. That's every year. So you can see it's 25,000 in year two, 30,000, and then so on. And he predicts this pattern will continue until it reaches 100,000, and then he will continue to make £100,000 a year profit every year after that. So the first question is, calculate the profits of Bruce's company in the first 20 years. Right. Now, I always like to write the sequence down. So when you're modelling with sequences, it's really important to put some sort of context on here. So we've got year one, we've got 20,000. Year two, I'm just going to write down pretty much what they've told us, 25,000. Year three, 30,000. We're not really meant to write commas anymore, but it just makes it so much easier for me to see the numbers. And this question for part A is a bit strange to get your head around at first, because does that mean how much profit is in 20 years time, or calculate the sum of all the profits from the first 20 years? So if you think about it, if you said to someone, well, what was the profit of your company in its first 20 years? That would mean the sum, yeah? So even though it doesn't say the sum, it is actually implying that. So that's what you've got to be aware of. Well, that's a bit tricky because it doesn't... This is an arithmetic sequence here. We can see A is 20,000. Let's write this down. So A is 20,000. And the difference is 5,000. But the problem is this bit here, where it starts to... it stops when it reaches 100,000. So the first thing we've got to do is work out after how many years is the profit going to stop increasing and just remain stable. So to do that, we need the nth term of an arithmetic sequence, and that is a plus n minus 1d. And we want to work out when the term is equal to 100,000. So 100,000 must be equal to 20,000 plus n minus 1, that's the bit we want to work out, and we know the difference is 5,000. So let's take away 20,000 and divide that by 5,000, and that will give me n minus 1 is 16. So n is 17. So what that means is in year 17 we have 100,000. Year 18 we have 100,000. And that's going to continue until year 20. Well, it's going to continue after that, it's just this question stops at year 20. So we need to find the sum of the first 17 plus 300,000, because it's year 18, 19 and 20. Right. So let's just make this bit a bit smaller, because we've dealt with that. Now, for the sum of 17, you've pretty got two methods here. So you could go for this one. So just the standard sum of a sequence. So you're more than welcome to go for that one. Or you could also go for this one, because you do have the first 20,000 and you do have the last term in the sequence is 100,000, and this is going to actually speed things up. So let's do that. So sum of 17 is going to be 17 over 2. The first one is 20,000 and the last one is 100,000. And when we work this out, let's just type it in my calculator. We get, what's that? 1020000. So just double check that. Yeah, okay. And when I'm putting my commas in, I just work from the back every three. So that's 1,020,000. But we're not after the sum of the first 17 years, we're after the sum of 20 years, so that's going to be plus our 300,000 for the years 18, 19 and 20, so that's 1,320,000. Not bad. Okay, so let's again make this all a bit smaller as well. Wonder if I can just bung that down there. Yeah, I can. Cool. Right, part B. Maybe we'll just verbalise this one. But state one reason why this is not a suitable model. So, do you know, if you know anything about businesses, a lot of people say you can't expect to make a profit for the first 3 years. You're going to make a loss, and you've just got to be able to stick that out and look to the future. So, you could say businesses or new companies are unlikely to make a profit in their first year. You could say something like that. So 20 grand is being a bit hopeful. You could go just for the really simple option and say it's unlikely to make a profit of a fixed amount every year. So, and if you weren't sure, well, part C, actually, just looking at it now, kind of hints that. So in part C, it says Bruce's financial advisor says yearly profits are likely to be a percentage, not a fixed income. So there you go. It kind of answered part B for you. So use this model to calculate the profits for Bruce's business in the first 20 years. Right, so year 1, it's still 20,000. Year 2, it's now 20,000 times 1.05, and that is 21,000. And then year 3, we times that by 1.05 again, we get 22,050, and that is going to continue on for the until however far we want it to. In this case, 20 years. Right, so this time we have a geometric sequence. So A is 20,000, R is 1.05, so we can use the sum of a geometric sequence. So they all start with A, or both start with A, and R's more than 1, so that's going to make it more user-friendly, so therefore I go R to the n minus 1. I want the sum of the first 20, so sum of 20 is going to equal A, 20,000, 1.05 to the 20 minus 1, and that's going to be divided by 0.05, and when you work that out, you get 661,319, and just remember it's money, so you have to write this to 2dp. Right, so there you have it. So you can see the difference in the it's half. Okay, so that's why the percentage is probably more realistic. But like I said to you, if a business makes a profit in the first year, wow, nice work. Let's have a look at another one. So we've got a piece of paper, it's folded in half repeatedly. I love this question because it's one of those challenges. I can't even remember what the answer is. I think it's 6 is the most times you can fold a piece of paper, an A4 piece of paper. You can try it when you're bored in isolation. So a piece of A4 paper is folded in half repeatedly, and we're starting off with 0.5. So this is at the start, okay? A4 paper is 0.5 millimeters. So if we fold it one fold, okay, well now it's going to double, isn't it? It's going to be 1 millimeter. And then we're going to double it again. So if we double 1, we get 2, and that's after 2 folds. So 3 folds is going to be 4, 4 folds, and I've just realised I've answered the first question. Now, that's pretty easy to do that bit. But what I'm going to suggest you to do is actually, can you use some sort of formula to work this out? Because this is a number we can check, make sure our formula works, and then we can apply it to B for 20 folds. So, what type of sequence is this? Well, this must be a geometric, and we can see starting at 0.5, and R is 1. But we're not after the sum, so we're just going to go in for the nth term, which is un equals a r to the n minus 1. Now, the danger with this question, most people would do, especially if they haven't just done the basic start like I have, they will go for the fourth term because they go, oh, 4 folds, fourth term. But is it? Look, no. This is the first term, second term, third term, fourth term, fifth term. Right, so that has to be a 5. Now that's what I mean. So we know it's 8. We've already worked it out. We don't have to do this, but just to make sure our formula is correct, it's going to save me some embarrassment later. So A is 0.5. R is not 1, you Wally, it's 2. So it's 2. N minus 1 is going to be 4. So 2 to the power 4 is 16. Half of 16 is 8. We know our formula is spot on now. So let's go for B. Let's pop B over here. So 20 folds, well, that is the 21st term. Okay, we can see the number of terms is always one more than the number of folds. So we're going to go for U21 is 0.5 times 2 to the 20. And let's just type that in. Wow, it's a big number. This is why it's not possible. 52488 millimeters. Right, so that's 524 meters. You know, you think how big that is. That's why you can't do it. And you know, I think it fails. Maybe even after 4. Maybe you can't even go past 4 folds of a piece of paper. But why not try it? State one reason that it's unrealistic. So just do what I just said. You can't fold a piece of paper 20 times or more than 4 times or 6 times. And for 20 folds, that piece of paper would be 524 meters high. So, you know, that's massive. Right, one more. Let's do one more. So at an archaeological dig, a team can process 3 cubic meters of ground a day. Write down a formula of how much ground they've processed after n days. Okay, so like before, we're just going to write out the formula. So day 1, that is 3. Day 2, that would be 6. Day 3, 9, and that's going to keep going. And what we're looking for is day n. So what would this be? So this is a arithmetic. So a is 3, and we have a constant difference of 3. And the nth term for an arithmetic is a plus n minus 1d. Right, so let's just pop this information into here. So we've got 3 plus n minus 1, lots of 3. So it's 3 plus 3n minus 3, but that's just 3n. Simple enough. Let's go to part 2. So how many days will they have processed more than 430 cubic meters? Now you may think this next question is quite straightforward, but I think it's tricky because it's the language of the question that's a little bit ambiguous for me. So when I read that, my first thought is the temptation is to find the sum, and that's how far we've got. But what that would do to find the sum, that would mean after day 2, for example, we would have done 9 cubic meters, but after day 2, that is 6 cubic meters. After day 3, there's only a total of 9. If we found the sum of all 3, we'd actually have 18. So we're going to get to this total of 430 very, very quickly. And that just isn't the case. This is already a sum, like a series, if you like, this number. So this is 3 a day. So this is 3 for day 1 and 3 for day 2. So actually the sequence is just an nth term sequence. So it's 430 equals a, but I'm just going to write the formula again. And it says more than, so I'm just going to find it equal to it and then, you know, think about my answer at the end. So you go 3 plus n minus 1, 3. Didn't really need to do that, did I? Because that just works out to be 3n. And when I do 430 divided by 3, I actually get 143.3 days. So obviously that can't happen. Well, it's going to happen in the 143rd day, but for it to be more than that, we're going to say the number of days must be 144. Again, that answer is a bit rubbish because, yeah, on 143 days, it's lower than 430. In the 144th day, it's going to happen, and it's also going to be more than that in that day. So yeah, okay, that's the answer. So if you actually, I'm just going to pause the video and just quickly work out what it would be if you find the sum. Okay, so if you found the sum of all of these numbers, this would actually happen on day 17, so you can see it's really different. So it's really important to think about your question and have you understood the language.